Welcome everybody. 3-1 additional practice. Determining whether a relation, which is just a set of ordered pairs, is a function. Okay? Or does each input have exactly one output, as Mr. Fricky taught you so well. Number one, okay? If we look here, set of ordered pairs. This called a relation. Called a relation. Make an arrow diagram that represents this relation. Folks, we're going to draw two ovals. Okay? Oval on the left represents our inputs. Oval on the right, output. Okay? Now, as we go down these, we don't need to list an input more than one time. So even if there's multiple of the same, for instance, there's a 1 here and a 1 here, we only list it one time. Okay? I see a 3, a 3, a 6, and a 2. I'm going to list these in order. 1, 2, 3, and 6. Okay? Output values. All my different Y values here. Starting with the smallest one, I got a 4. I've got a 5, a 6, a 7, an 8, and an 11. Okay? And for the arrow diagrams, we just match ordered pair. Input value with its output. The 1 goes to the 7. The 3 goes to an 8. The 3 goes to a 6. The 6 goes to a 5. 2 goes to the 11. And the 1 goes to the 4. Okay? We just drew what's called an arrow diagram. Sometimes it's called a mapping diagram. But now we need to look. Letter B says, is this relation a function? Well, does any one of these inputs have two different arrows going off of it? Yeah, this one got two different outputs, and this one has two different outputs. So is this a function? No. Okay, no it's not. And we're going to explain, because it says explain, each input does not have its own output. Okay? Boom. Questions? Okay, let's move on. We got to look at this table. Does each input on this table have its own output, folks? If you listen to Mr. Fricky, all we have to do is look at the X values here. Look at our input values. Read them off. 1, 2, 3, 4. Did I ever say the same number twice? No. So is this a function? Yes. Each input has exactly one output. Okay, so yes, this is a function. If we look at number 3, the relation shown below represents the temperature in degrees Celsius of the air a certain number of hours afternoon on a wintry day. Is the temperature a function of time? Well, again, all I got to do, folks, look, read the X values. 2, 1, 6, 4. Did I ever say the same number twice? No. That means, yes, this is a function. Why is it a function? For the same reason here. Each input has exactly one output. Number 4, make an arrow diagram to represent this relation. Okay. Input values go here. 1, 11, 15, 16. Output values. I got a 2 and I got a 32. And I connect 1 with the 2, 11 with the 32, 15 with the 2, 16 with the 32. Is this relation a function? Well, go to the inputs. Do any of these have more than one arrow? 1, 1, 1, 1. Or if I just look at the table, 1, 11, 15, 16, none of these input values repeat? Yes, this is a function. Why? Each input has exactly one output. Moving on down. Oh, here we go. Set of ordered pairs represents the cost of tickets for the school play for different number of tickets. The input represents the number of tickets, and the output represents the cost. Is the cost a function of the number of tickets? Well, let's go to the X values. 1, 3, 5, 6, 7. Did I ever repeat myself? No. So is that a function? Yes. And if I wanted to go back and say, why is it a function? Each input has exactly one output. Okay, moving on down. Number 6, part A. How can an arrow diagram help to determine whether a relation is a function? If each number on the input has one branch coming off of it, it's a function. Okay? If each input number has one branch, it's a function. Letter B, make an arrow diagram that describes this relation. 339, 639, 978, 15, 117. Input, x values, 3, 6, 9, 15. Output values, 39, 78, 117. 3 goes to the 39, 6 goes to the 39, 9 goes to 78, 15 goes to 117. Okay, make an arrow diagram. We did. Is it a function? You betcha it is. Okay, 1, 1, 1, 1. Each one of these inputs has one branch coming off of it. Okay? Moving on down, we're going to skip 7, going to number 8. Is that a function? Is this set of ordered pairs a function? Well, how many branches? 1, 1, 1, 1, 1. Does each one have one branch? Yes, it does. What you mean? Yes, it's a function. Why is it a function? Each input has how many outputs? 1. Each input has exactly one output. Number 9, there's going to be 2 choices here. Which of these are functions? Select all that apply. Well, again, all I'm going to do is go through and read the x values. If I ever say the same number twice, I'm not going to choose it. Because if I say the same number twice, it's not a function. 4, 5, 6, 6. Whoa, I said 6 twice. Not choosing that one. 6, 7, 8, 8. Nope, not choosing that one. 4, 5, 6, 7, 8. Yeah, choosing that one. 7, 8, 9, 10, 11. Yeah, choosing that one. Folks, that takes care of the 3-1 additional practice. Hopefully it helped.